Welcome back for another Best Practices video. I'm Jamie Velasquez-Spady, and today we're going to look at the third grade unit for perimeter. What do you notice? What do you wonder? In this video, we see students using units to measure the perimeter of the given shape. Now, this is actually from our STEMscopes second grade Explore because second grade is now going to be the foundation of perimeter. However, our incoming third graders didn't get that last year with maths, so this would be a great engage piece for them. Third grade unit for perimeter, students will be solving mathematical and real-world problems involving perimeter of rectangles with whole number side lengths using a visual model and a formula. Students should understand that when finding the perimeter of a square, the length is the same as the width. This means the same number will be added 4 times or multiplied by 4. The formula is perimeter equals 4 times the side length. Now, this formula might differ from other formulas students will develop for perimeter. Solving mathematical and real-world problems involving perimeter of composite figures composed of non-overlapping rectangles with whole number side lengths. Previously, we called these rectilinear figures. So what does student learning look like in the classroom? This first example comes from STEMscopes in the Foundation Builder. Because students have had no experience with perimeter prior to this unit, it will be very important that students are given the opportunity to figure out what perimeter means. What does that unit of measurement look like? Then students will be expected to measure the side lengths of rectangles, and as you see, add up all the side measurements to get the perimeter. Students will also explore hands-on composite figures. These tools are actually provided in the STEMscopes Explore materials, and students will be building the composite figures and then translating the hands-on models to a representation model in their student journals, and then also adding up all those side lengths to get the perimeter measurement. And lastly, in the third Explore, students will connect what they've been doing with hands-on measuring to representation of the rectangles and the side lengths to then develop a formula that will get them the perimeter measurement every time they apply it. And as you see, students might not only have one formula, but possibly 2 different formulas, and it's important to connect both of those formulas with your students. Throughout the unit and in these explores, students will be demonstrating MTRs 1, 2, 5, and 7. We want to encourage students to discuss what they understand about perimeter in this unit. These questions come from the math chat cards in our STEMscopes Explores. Questions about the tools students are using, the formulas they've developed, comparing measuring the perimeter of rectangles to the composite figures, and how students are interpreting the formulas that they developed for perimeter. These questions are great to get students talking to one another and using that precise vocabulary as they understand the measurement of perimeter. There is some important vocabulary in this unit. These vocabulary words come from the parent letter in STEMscopes: composite figure, measure or measurement, perimeter, real-world problems, rectangle, side lengths, square unit. All of these vocabulary words will be important for students to use in their discussions verbally and also their written explanations as they are doing work in the classroom. In addition to student discussions and some of the Explore activities we've seen, there are lots of ways that students can demonstrate their knowledge throughout the unit. There are tasks with the Explores, exit tickets connected, some fluency builders, decide and defend, and show what you know. As you see, a lot of these have open-ended responses with some potential examples here, and students will be working with not only rectangles, but also those composite figures. Here are some additional questions that you could ask students to gauge their understanding in this unit. Questions similar to this or additional questions can be found on mathsmarts.com. You can get there again by clicking on any of the hyperlinked benchmarks in our instructional guides. The first question asks, how can you find the perimeter of this rectangle? You can expect that students would explain that they could measure, or if they're given the side lengths, that they would add up all of the side lengths to find the perimeter. How does using a formula help when finding perimeter of rectangles? Hopefully students can articulate that using the formula assures that every time they are finding the perimeter of a rectangle, they're guaranteed to be able to find the accurate measurement. The last question is really important because we know that students can confuse the measurement of area and perimeter. So giving them a chance to really explain the difference and give examples of what both of the measurements might be. Measuring perimeter happens in the real world all the time. One of the tic-tac-toe choices from our parent letter tasks for at home is called perimeter in the real world, and it is just like it sounds. Students will work with their family members to create a list of situations in the real world where you would need to find the perimeter. An example, you can ask, how much fencing material would we need to build a fence around the yard? And your child can draw a model of that perimeter situation. What did Area say to perimeter while arguing? I'm trying to talk to you, but I feel like you're just going around my problem. I hope to see you next time. Thanks for joining me.